Good morning everyone. This is class 10 physics. Let's today discuss some definition of the physical quantity. The first one is heat capacity, symbol is C dash. It is defined as the amount of heat needed to raise the temperature of an object through 1 Kelvin. So C dash is equal to heat capacity is equal to heat energy needed divided by change in temperature. SI unit of the heat capacity is joule per Kelvin. The second component is a specific heat capacity. Here mass is needed, whereas here mass is not needed. So a specific heat capacity is defined as the quantity of heat needed to raise the temperature of unit mass of an object through 1 Kelvin. So C is the symbol for the specific heat capacity. A specific heat capacity is equal to heat energy divided by mass into change in temperature. The symbol is SI unit is joule per kg per Kelvin. Now the relation between these two, relation between C and C dash is equal to M into C. That is the relation between these two. Next is calorimeter. Calorimeter is basically a cylindrical vessel which is made of a thin sheet of copper. Now copper is used basically for two reasons. It is good conductor of heat and second it has low specific heat capacity. So it will acquire the heat energy very quickly as soon as it comes in contact with the hot object. Now the inner portion and the outer portion of the cylindrical vessel is painted so as to minimize the heat loss due to radiation. Then it is kept in a wooden jacket. Space between these two is filled with the wool which is bad conductor, so it will minimize the heat loss due to conduction. Now it is covered with a wooden lid so that it will minimize the heat loss due to convection. So here it is designed in such a way that heat loss is minimized and heat loss can be occurred due to radiation, conduction and convection. Next, principle of calorimetry. Principle of calorimetry says that if there is no loss of heat energy, then heat lost by hot object is equal to heat gained by cold object. So principle of calorimetry, heat lost by hot object is equal to heat gained by cold object. So this is the principle of calorimetry. Heat lost by hot object is equal to heat gained by calorimetry. So heat loss or heat gain is equal to mc delta T, where m is the mass, C is a specific heat capacity and delta T is change in temperature. Now mathematical statement. Next thing that we have to study is mathematical statement. Mathematical statement. For that, we will take two objects. This is object A, this is object B. Mass is equal to M1, this is M2. It is as temperature T1, it is at temperature T2. A specific heat capacity is equal to C1, it is C2. We consider A as the hot object and B as the cold object. So when these two objects A and B are mixed together, there is transfer of heat energy. Now heat will be lost by the hot object. So heat lost Q1 is equal to heat lost by A is equal to M1 C1 T1 minus T heat gain by B equal to M1 C1 T minus T2, where T is equal to where T is equal to equivalent temperature. Now, when we mix these two objects, hot and cold object, then hot object will lose the heat energy, so they are able to decrease in temperature, whereas cold object will gain the heat energy, so there is increase in temperature. A situation will come when both are the same temperature, and that is the equivalent temperature, that is the temperature which is between A and B. So this is equilibrium temperature, it is not equivalent temperature. T is equilibrium temperature. Now here we apply the principle of calorimetry, that is heat loss is equal to heat gain if there is no transfer of heat energy to the surroundings. Q1 is equal to Q2 M1 C1 into T minus T. T1 minus T is equal to M2 C2 T minus T2. So this is by principle of calorimetry. Next is natural phenomenon and consequences. Natural phenomenon and consequences of high specific heat capacity of water. A specific heat capacity of water, C is equal to, it is 4200 joule per kg per Kelvin. So this is the value of a specific heat capacity, that is of water, 4200 joule per kg per Kelvin. Now there is natural phenomenon that can be explained with the help of this high specific heat capacity. First one is the climate near the seashore. Climate near seashore is moderate. Now this is the land, this is seawater. Now seawater has different ability to absorb heat energy. Land has different ability to absorb heat energy. As a result, there is a great difference of temperature between land and sea. As a result, we will get the breezes. Two types of breezes is there. One is land breeze, the other one is sea breeze. So these two types of breezes make the climate near seashore moderate. Many more examples are given there. So go through that example. So this finishes your theoretical portion of part A. Next video will discuss the numerical portion.